Okay, for question 2, part 1, we are given the curve to be of the equation ay squared equals to x over 4 minus x. Okay, usually when I see these things, well, I will just rewrite it as 4x minus x squared. Because if you read part 1, we actually have to do differentiation. And we are supposed to find the equation of tangent which are parallel to the y-axis. Now take note, for equation of the tangent which are parallel to the y-axis, we actually have the gradient to be so-called undefined. Okay, note undefined. And the equation of the tangent will be x equals to something. Okay, because the tangent will look something like this, parallel to the y-axis, and the equation will be always be x equals to something. Okay, and the gradient is undefined. Undefined. Okay, so this just means that either you see as dy dx to be, well, negative infinity. Okay, should I put infinity? Or some of the tutors actually have taught you all that dx you can also see as dx dy equals to 0. Okay, now after we know what we need to do, we have to go and differentiate. Now to do the differentiation, well, you do not really need to take square root both sides. What you can actually do is you can actually do implicit differentiation. So we have 2ay, okay, okay. Thing is, in order not to confuse you all, I should rewrite the above equation as a square y square first, then differentiate implicitly. A square is a constant, hold it, so 2y dy dx equals to 4 minus 2x. So dy dx is actually equals to 4 minus 2x over 2a squared y. And for the dy dx to be infinity, we have 2a squared y to be equals to 0, implies that y equals to 0. Now, but you have to note that the equation of tangent is in terms of x equals something. So we need to put this value y equals to 0 back into the equation that we have. And we have x or bracket 4 minus x equals to a0 whole thing square. This will just means that x over 4 minus x is actually equal to 0. Now we have two values. Okay, x equals to 0, x equals to 4. Okay, we will actually accept both because there's no condition given to us whether or not we have any restriction on the x, and therefore technically for this curve we have at 2 points that the tangent is actually parallel to the y-axis, and the equations is actually equal x equals to 0 and x equals to 4. Okay, for question 2 part 2 is actually linked to your part 1 in the sense that we are actually using the same equation, except that in this case we know that the equation is actually a equals to 0.5. So what we actually have is, okay, we had this curve, and this curve, the equation is actually half y squared equals to x4 minus x. And we actually so-called cut out area that we actually define it as PQRS, and we are supposed to find out what is the exact value of the x that will actually make this area to be maximum. However, actually, first thing we have to show that the area of the PQRS is actually given as in the question. Okay, now the thing is this: in order to get the area of this, we know that we have to get the length of PQ and the length of PS. And and we are only given that, okay, if I let P to be x comma y, the area of PQRS should be shown as such. Now at first sight, these questions may look a bit difficult for you. However, if we actually use a bit of symmetry of the diagram, we will be able to find out what the length of PQ and the length of PS easily. Now what do I mean? Now by symmetry, if this point is actually x, and we also know that this point here, okay, where the point actually the so-called ellipse actually cuts the x-axis again, is actually 4. We know that this point here is actually 4 minus x. Okay, so if this is the case, then what we can actually see is this small little length and this small little length is both x, and hence length of PQ is actually equals to 4 minus 2x. Okay, the whole length actually minus of 2 times of the x. Then next up is that if I know that this point is actually defined as y, okay, this whole length as y, by symmetry, this whole length will be actually just 2y. So what we actually will have is that area of PQRS is actually equals to 2y multiplied by 4 minus 2x. And you actually, if you actually factor out the factor 2, what you actually have is 2 minus x. Note, you actually have some of the things that you are required to show there already, 2 minus x. So what do I actually do? Well, if you look at the whole equations, we actually will have to make y in terms of x. So returning back to the equations that we have, half y squared equals to 4x minus x squared. What we actually need to do is to actually need to take square root. Now in this case, for the square root, we do not actually need to care about plus and minus, and we just take it as positive because we are actually looking at length. And the y itself, we have to take the positive values. So this will be the y value. And if you put the thing back into the equations, what you actually have, okay, let's write this carefully. It's square root 4x minus x squared multiplied by 2 minus x. And that is precisely what the question needs us to show. Okay, so now after we got the thing, we are ready to actually differentiate. So better use an alphabet to represent the area so that later we can do the differentiation easily. Now, and again, note one thing. The difference between question 2 and question 1 right now is that the values of x that we have to find is exact. So there's no choice. Later we will have to really solve, okay, it. So a equals to 8 square root 4x minus x squared, 2 minus x. And because there's a square root, there's no choice, but okay, I have to rewrite it like this first. Half 2 minus x. And when I do the dA over dx, there's no way that I can do it. I can actually simplify the whole equation into term by term. So product rule have to be used. So hold the first, differentiate the second, plus hold the second, differentiate the first. Okay. Now the thing is, well, I have to let this, because we are looking for minimum, before you even go and simplify, we know that we have to let dA dx equals to 0. So this whole thing is actually must be equals to 0 to find out what the x value is. Okay, the half multiplied to the 4 minus 2x will give you 2 minus x. And this whole thing must be equal to 0. And what we can actually do is, we can actually factor out this thing here. and this will give me this 2 minus x, 2 minus x equals to 0, and this whole factor here can be multiplied over, and what I need to do is to just simplify this bracket inside. Minus 4x plus 4 minus 4x plus x squared equals to 0. So what I have is 2x squared minus 8x plus 4 equals to 0. X squared minus 4x plus 2 equals to 0. Now, the question actually needs you to actually solve it in exact. Well, this is not hard since we are actually dealing with a quadratic equations. You just need to apply the formula minus b, 4 plus or minus b squared, which is 16 minus 4 ac over 2a. So your x is equals to 2 plus and minus square root 4 plus and minus square root 8 over 2. So okay, so it's 2 plus and minus square root 2. Now x equals to 2 plus and minus square root 2. Well, in this case, you will actually need to go and test which values will actually give you the maximum. The thing is, you won't really want to actually do the calculation again. Sorry, it's not a calculation, it's to do the differentiation of dA dx to find d squared a dx squared again, because it's going to be very complicated. So in this situation, I will actually suggest that you actually do the exact calculation for this table to actually find out which x will give you the maximum. So one of the value that you can actually test is 2 minus square root 2. So you just select the value minimum. And the other one is actually the positive one. Okay. So what you can actually do is you can actually do the calculation using your GC, and you really have to do this in examination, the calculation. However, the calculation I think can be done quite easily. So this one is 0, 0. Now if you would do the calculations, what you will actually see, sorry, there's a mistake here. What you actually will see is that for the value here, you will actually get it as positive and negative. That's giving you this shape. And this one will give you negative, positive, that's giving you this shape. So the value whereby it's actually maximum is actually at x equals to 2 minus square root 2. So conclusion, at x equals to 2 minus square root 2, area is maximum.